In this video, we'll give a brief introduction to compound interest. Now, when we talked about simple interest before, we told you that the interest earned is only on the initial amount. But when you're dealing with compound interest, let's say if you were to leave an amount in let's say a savings account that compounds it monthly, and you leave it alone for 2 years, then you'll earn interest not only on your initial amount, but after each month you'll earn interest on your interest. So that means it grows at actually a greater rate. And that the more times it's compounded per year, the actual faster the rate is. Now the following are the formulas for the compound interest, especially when you're trying to find the future value. Now the formula states that A is equal to P times 1 plus I raised to the n. Now this is saying that the future value, how much will be in the account after so much time, is equal to the present value P times 1 plus I, where I is the interest rate per period. So it's not the annual interest rate unless it's compounded annually. It's how much interest you earn per period. So for instance, if they told you that the annual interest rate was, let's say, 6% and it was compounded monthly, this means that each period you don't actually earn 6% each month. It means you earn 6% divided by 12, which would be 0.5% each period. So in that case, the I would be 0.005, because you got to make sure to put your interest rate in decimal form. So another way to think about it is that the interest rate per period is equal to R over M, which would be the annual interest rate divided by M, where M is the number of compounding periods in 1 year. So like I was saying in that previous example, if it was an annual interest rate of 6% and it was compounded monthly, then it would be 0.06 divided by 12. And now the rest of the formula says that it's the 1 plus I raised to the n, where n is the total number of compounding periods in the problem. So let's say if it was compounded monthly for, let's say 2 years, then the n in that case would be, well, if it's compounded monthly, that means it's compounded 12 times each year, and then it's for 2 years, so it would be 12 times 2. So n in that case would be 24. Now another way to think about this formula is that the future value is equal to the present value times 1 plus R over M, because that is I, the interest rate per period, raised to the M times T, because the M times T will give you where M is the number of compounding periods in 1 year and T is the number of years. That'll get you the total number of compounding periods for the problem. Now for the first example, let's find the compound amount, that means the amount you would have at the end, if $1,000 is deposited at 4% compounded annually for 6 years. So for this problem, our present value, the amount that we're initially investing, is $1,000. R is 0.04, the annual interest rate in decimal form. M is equal to 1 because it's compounded annually, which means it's compounded 1 time per year, and T is equal to 6. Now since the interest rate is compounded annually, the interest per period is actually the same thing as the annual interest rate, because the interest per period is R divided by M, which would be 0.04 divided by 1, which is just 0.04. And the number of compounding periods, well again, since the interest rate is compounded annually, that's just the same thing as T, because it's compounded 1 time per year and it's compounded for 6 years. That means N is equal to 6. So plugging this into the formula, we get that the future value is equal to P times 1 plus I raised to the n, which would be in this case 1,000 times 1 plus 0.04 raised to the 6. Now the first thing I'll do is add what's inside the parentheses. And 1 plus 0.04 would be 1.04. Now I'll raise that 1.04 to the 6th power and then multiply that by 1,000. So plugging that into the calculator, I'll get 1,265.319018. Now let's round it to 2 decimal places since we are talking about money. So the compound amount, which is the future value, would be $1,265.32. Now let's just illustrate how this would be different than if you had done this with simple interest. Now remember, the simple interest formula is that the future value is equal to P times the quantity 1 plus RT. So that would be 1000 times the 1 plus 0.04 times 6. And if you plug that into your calculator, you get that the future value would be $1,240. So you see that that's slightly less than using compound interest, because with the compound interest, after the first year, not only do we earn interest on the initial amount of $1,000, but we would earn interest on the interest as well. Now with the next example, what we're going to show is that even if we were to invest the same amount at the same annual interest rate and the same number of years, what we're going to show is that the more times it's compounded in 1 year, the more interest you actually will earn. So you're told to find the compound amount of $1,000 is invested at 4% compounded monthly for 6 years. So in this case, it's compounded 12 times per year instead of just 1 time. So P in this case would again be 1,000, R would still be 0.04, but now M is equal to 12 and T is still 6. So what we get that is that the future value is equal to 1,000 times 1 plus, now the 0.04 divided by 12, because if the annual interest rate is 4% and if it's compounded monthly, you take 1/12 of the 4%, which would be that 0.04 over 12, and that's how much you earn in interest each period, and that's raised to the 12 times 6, so that's 72, because again, if it's compounded for 6 years monthly, that means it's compounded 72 times. So what I'll do next is just to plug this all into my calculator, see what I get, and then rounding this, let's say, to 2 decimal places. The future value, the amount that would be in this account would be $1,270.74. So you see that if it's compounded monthly compared to if it's compounded annually, you would earn a little bit more money in interest. Because if you want to see exactly how much have we earned in interest, you take the future value minus the initial amount. So the 12,070.74 minus 1,000 would be $270.74 in interest. Anyway, you see that the more times it's compounded, if the annual interest rate is kept fixed, the more interest you'll earn. Now, if it had been compounded, let's say semi-annually, that means it would have been 2 times per year. It would have been a little bit more than annually, but less than if it was compounded monthly. And let's say if it's compounded quarterly, that means 4 times a year. Again, that's the future value would be somewhere between if it's compounded semi-annually and if it's compounded monthly. And then if it's compounded daily, that means, well, for a standardized value that they use is that in that case is they say it's compounded 360. Just that way some numbers come out a little nicer and you don't have to worry about if it's a leap year or not. And then if it was compounded daily, then you would actually earn a little bit more money than if it was compounded monthly.